Events. An event is a possible outcome of one or more variables. When we talk about one variable, the outcome is called a single event. For example, when we draw a card from a deck of cards and we draw a red card, then the color is the variable. If you have two or more variable, the outcome is called the joint event. For example, when we draw a card from a deck of cards and we draw an red ace card and the variables are color and type. That's called a joint event. The complement of event A for any event A is all possible outcomes but A itself. For example, if assume A is the event of drawing a red card, then A apostrophe, which is the complement of event A, is not a red card. That means it has to be a black card. Sample space. The sample space is the collection of all possible events or outcomes for a random variable or a set of random variable under study. For example, suppose that we want to study the outcome of tossing dice. What are the outcomes? What are the possible outcomes? It can be 1, 2, 3, 4, 5, 6. So all the 6 faces of a dice is all the possibilities. So this is going to be the sample space, the all possible outcomes of a variable. Or for example, we draw a card from a deck of cards. How many possibilities do we have for the card? We have 52 possibilities because we have 52 different cards. So these 52 different cards, the type and color, would be the sample space. Some basic probability concepts. Starting with probability itself. What do you think probability it is? How do you define probability? Try to think about this. A probability is the chance of an uncertain event happening. And it's always a value between 0 and 1. If we define it as a percentage, then it's going to be a value between 0 and 100%. Now, what do we think an impossible event is? An impossible event is an event that has no chance of happening with 0 probability. For example, we toss a dice. What is the probability of getting a 7? Well, that's 0. That's an impossible event because we only have 6 faces on a dice. How about a certain event? What do you think a certain event is? A certain event is an event that is sure to happen with a probability of 1 or 100%. For example, we toss a dice. What is the probability that it's below 10? Of course, it's going to be below 10. All the 6 numbers are below 10. So that's a certain event. It's going to happen for sure. How do we find the probability? This is a simple formula for finding the probability. Probability of event A is the number of possible ways that event A can happen divided by the total number of possible outcomes, which is the total number of events that we have in a sample space. So n is equal to n of A divided by n of S. N of A is the number of ways A can happen. N of S is the size of the sample space, which is the number of events in the sample space, which is the total number of possibilities that you can have. So that's a basic but very important formula for probability. We're going to use this probability to find the probability of different events. Let's see an example. Suppose we want to find the probability of drawing a face card, either a jack, a queen, or a king, out of a full deck of cards, which has 52 cards. So please pause, work on this example using the simple basic formula that we learned for probability, and then come back to see the solution. Right, let's see the solution. So a face card is either a jack, a queen, or a king, and we have 4 of each. So if we define, for example, A as the event that a face card is selected, and S is going to be the sample space, the event that any card is selected, we can find the probability of picking or selecting drawing a face card as the number of face cards divided by the total number of cards. So the size of n, the number of ways that you can select or draw a face card divided by the total number of sample space. So we have a total of 12 face cards. So that's 12 divided by 52, which is 3 divided by 13, which is about 23%. Examples or scenarios like this that we use logic to find the probability, and you don't use any past data, is called priori probability. So it's totally based on logic and independent of any past data. It means that if we find this probability in future, or we have found it in past, it doesn't matter. It still would be 12 out divided by 52. This is opposed to the type of probability that we're going to talk about later, that is based on past data and not based on logic. Let's see another example. Suppose we have a population of students. We have female students and male students. Some of these students have taken statistics. Some of them have not taken statistics. As you see this in table, this table shows all the information data for this population. Find the probability that we randomly select a male from this population who has taken the statistics. So we randomly select a person. Suppose that someone blindly pick a students from this population. What is the probability that that student is a male who has taken the statistic class? So please pause, work on this example, and then come back to see the solution. You should go step by step. First, define the event that you are looking for. Here is a male, selecting a male student who has taken a statistic class, and then use the formula, the basic formula. The probability of event A is equal to the number of ways A can happen divided by the total possibility or the sample size. All right, let's see the solution. So the total number of male students who have taken the test is 84, although we have 299 male students. Out of these 299 students, 84 have taken a test and 145 have not taken a test. So we don't care about those students. And we have a total of 439 students. Out of these, 229 is male, 210 is female. So let's define our event. We define M, for example, as the event that a male student who has taken the statistic class is selected. And S is going to be the sample size, the sample set, which is the total number of students here. So the probability of selecting male students out of this would be the total number of male students who have taken a test, which is 84 here. So 84 divided by the number of sample space, which is 439. So the probability would be 0.191, about 19%. This type of probability that you see is different from the previous example that we have because we didn't really use any logic. We used the data that we had here. If we use this, if we apply this method on another population of students, with different number of male and female students, with different number of people who have taken a statistic class or not, then we would get different probability. We would get a different number here, the different probability. So this type of probability is called empirical probability because it is calculated on past data, the table that we had here. And it's going to change if we use different data. Simulating tossing a coin. If we toss a fair coin, we are going to get either a heads or a tails, with each outcome equally likely if the coin is fair, meaning that it's in good condition, it's not biased. So we say that the probability of getting a heads is 50%. But what does it exactly mean that the probability or the chance of getting a heads is 50%? Here I want to do a simulation in Excel to show you what does this mean. When you toss a coin, the outcome is going to be random. You don't know whether it's going to be a tails or a heads because tossing a coin is a random experiment. To simulate that in Excel, I'm going to use a function called random function, which is going to generate a random number between 0 and 1. This function, you can use this function as many times as you want. So I want to use this function to simulate tossing a coin experiment. So how can we do that? We need to set up a setting here for the experiment. So I would say if the number generated is less than 50%, we consider that as a head, as a tails. If it's greater than 50%, we consider that as a heads. So now when I want to run simulate the tossing coin, I toss the coin. I don't know whether it's going to be a heads or tails. I generate a number. You don't know whether it's going to be less than 50% or more than 50%. Now, this shows that the coin is landed. The number is greater than 50%. So we can say, okay, the coin is actually a heads. If it was less than 50%, okay, the coin actually landed on a tail. So with this setting, we can actually simulate the tossing the coin experiment here. Using this setting, I have generated 10,000 random numbers here. And if the number is less than 50%, again, it's a tail. If it's more than 50%, it's a heads. And I have plotted this data here on this graph as you see here. So the y-axis shows the percentage of the times that we have got a heads. Okay. And the blue line here shows the half of it, which is 50%. So the blue line is just a line. It shows the 50% percentage. And the x-axis shows the number of times we have done this experiment, or the total number of times that we have tossed a coin in this simulation. As you see here, for the 10,000 times, for the 2,000 times, as you see here, the percentage is not exactly 50%. But as we run this experiment long enough, you see that the percentage of getting a heads is about 50%. And that's what it means when we mean that the probability of getting a heads is 50%. It means that if you run this experiment long enough, the percentage of the time that you're going to get a heads is 50%. You're 50% of the time you're going to get a heads, 50% of the time you're going to get a tail.